Hey, Rich.
Good morning.
Morning. Hi, Justin. Thanks for joining us.
Hey, Anu. Hey, everyone.
We usually start a couple of minutes after 8 to get allow people enough time to join it. So just hang in there. Okay, I think we have some amount of critical mass. People will join as they get time. So my agenda, the main item was Justin from Siemens talking about their verification IP for both UCIe and Bo. But before that, let's go through a few house cleaning items. Um, I was going to just ask for feedback from the Global Summit because last week we had a rather thin audience. Uh, and I just wanted to know for those who had come to the summit and hadn't told us what they really felt. We'd like to get some feedback if there are any volunteers now, or you could email us.
Hey, I know I'll give you some feedback. I thought it was incredibly busy and successful from that standpoint. I'm not sure how many people were there who are really into chiplets and the development side of things, the chip development side of things. It was the focus was really on, the heavy iron and cooling and racks. I mean, it was on and connectivity. So, I mean, that was obvious, right? So I don't think I'm saying
Right.
anything new. It might have been good if there was, you know, a section that was dedicated to, let's say, the chip side. I mean, right now we have Innovation Village, which had everything in there, right? So if somebody was interested, I think it would be very difficult to find. If you were interested in, the development side of chips and the IP and things like that. So that's just a thought, right? So, and I had some people who were coming there to meet me, and even though I said it was innovation, within the innovation village, it was tough to find people. And we were more to the edge as opposed to being stuck right in the middle of the innovation village. So just a thought, right? So
Yeah, I agree that, even though like I always feel we do a lot of the building blocks for what then goes into these giant systems, um, but we kind of get lost in those giant systems. Um, just because those giant systems are so overpowering and it's hard to dig down deep, and I don't know how many people want to actually dig down deep to find where we are. But I think it's good feedback. Um, Cliff is here too, so any comments, Cliff?
No, I understand that the chiplet side of things is a smaller part of the community. We can take it into consideration about how we might make it a little bit more easy to find it and make it a little more visible. Part of the choice that I think the community is facing is, are you writing for people in your community? In which case, the 30 or 40 or 50 people that come to the regular calls are who will be interested in what you're writing for and the presentations you do? Or are you going to try to write for a bit more of a general audience to bring in others? And I say that just by looking at some of the titles of the presentations. If I wasn't someone from the community, I wouldn't know what they mean or why I might care to spend 20 minutes listening to it. So something to consider going forward. What does the community want? I'm not making a case one way or the other.
Okay, yeah, no, I think that's interesting. I never thought of it as looking at it from the outside in as someone who doesn't know anything about what we do. And you look at the titles of the talk about the work streams and they're like, huh? What does it mean?
Exactly. But BOW 2.0 would mean nothing to me.
Right. Okay, something to think about. And I think I wrote up a blog trying to promote at least the viewing of the recordings. And I'm sorry, I'm still in Phoenix. I've been here all week on work, and it's been one crazy week for me. So I will get back to you, Cliff, about I know you sent some stuff for feedback, but I've been going a little insane.
Sure. As soon as you get a moment, that'd be great.
Yes. Okay. Thanks, Cash. That was good feedback. Anyone else? Okay. Um, Cliff, the one thing I don't know if we should take this offline. I copied you in a mail from John Stewie about the server committee meeting. We were trying to get Mark Knight in. Usually it's a monthly meeting, November or December. Looks like that because of Thanksgiving and the holiday season, that's not, they weren't planning to hold a meeting November or December. And I didn't quite know between you and Mark, and I think Mark's on the call, maybe?
Yeah, hi. I sent an email about 10 minutes ago, or actually about 15
shoot.
minutes ago.
Okay, I
You
didn't
probably
check.
haven't
Yeah.
seen. So my proposal is first meeting of 2026 should be fine, to be honest. So
Okay, good, good. That was easy resolution. I appreciate it, Mark, because I was just trying to figure out how the heck we'd get that any sooner if the whole world is on vacation. So
no, I think that's fine. And yeah, Thanksgiving's important. And I think we're presenting Foundation Chiplet System Architecture in this call next week. So
yeah, I've got you.
looking forward to that.
Right. So just for everyone on the audience, because it's a pretty good sized audience today, we've got Mark from ARM talking about the foundation CSA that ARM is contributing to the OCP, and he'll have some more details on the work stream that's going to start. So that should be interesting. And then in a couple of weeks after that, I have Tenstorrent coming in to talk about their OCA. And I'll of course send out the agenda so folks know, but we've got a couple of interesting topics, very interesting to anyone building a ecosystem that needs to work based on Chiplet. So thanks, Mark, appreciate it. Cliff, do you want to talk about Chiplet Summit briefly before we give Justin the reins?
Yeah, absolutely. I just thought it'd be good to I thought it'd be good to let everyone know that we are planning to have a presence at the Chiplet Summit this year again. We will have a keynote. OCP will have a booth, and we will have the afternoon tutorial. And currently, Anu and Jawad are working at curating who we might like to invite for that afternoon tutorial. So stay tuned on that.
Thanks, Cliff. Jawad, anything to add?
If somebody is interested in independently dropping in proposals to speak at Chiplet Summit, please definitely inform us so we may be able to coordinate with the organizer a little bit.
Yeah, thanks, Jawad. We're probably going to have a pretty solid draft of the agenda lineup in the next week or two. So now's the time to speak. We've already reached out to a couple of folks, but there's still some wiggle room.
Okay, sounds good. Thanks, Jawad. Thanks, Cliff. And I think we should give the reins to Justin. Justin, I have to tell you, this is one of the largest audiences I have had on a Friday call. I'd like to say it's thanks to me, but I think it's thanks to you. So go ahead. It's all yours.
All right. Thanks to you, Anu, and to Rich for the invite today. So let me go ahead and share my screen. And I'm going to keep this presentation kind of informal. This is kind of a last minute setting this up, and I'm not very familiar with the who all is in the audience and what your interest is in verification IP. But I know there's a common interest uniting everyone here in terms of the chiplet economy. So with that, I'll go through these slides on the topic of verification IP, mostly focused on UCIe, because that's been where most of our effort at Siemens EDA has gone. And I'll touch on a bunch of wires as well. And feel free to interrupt me at any point if you have any questions.
Justin, you're not sharing right now. I'm not sure you're trying to.
Okay. Yeah. Trying to. Just give
Yeah,
me
I
one
know.
moment.
It's sometimes a fine art.
I'm more of a Teams user, so.
Yeah, that makes lots of us.
All right. Just give me one moment here.
Mm-hmm.
now. Is that correct?
Yeah.
Let me get this out of the way. Okay. All right. So the first thing I'll share, just to give some context and why I think verification IP is important part of the ecosystem. This is actually a set of slides I shared at Chiplet Summit last year during one of the tutorials, and you know, even back then, just earlier this year, we could see there's just a growing marketplace for chiplets. There's a lot more companies that are participating in, not just disaggregating their own SoCs for internal projects, but there's companies that are coming into the ecosystem developing chiplets that they want to sell openly on the market. So the chip system and packages can be built with multiple chiplets from different vendors. And that really comes down to a lot more than just the connectivity, the die-to-die interconnects, although there's a lot of standardization around UCIe and a bunch of wires that's helped in that area, but even the system level management, the software ecosystem that gets built around chiplets to be able to make that possible. And so we've seen increasing enthusiasm in the open chiplet economy. Workstream here is evidence of that, for growing an open chiplet economy and really trying to standardize the way these chiplets can be interconnected. And so specifically with the interconnect standards gaining traction, we have seen mostly with Siemens EDA a lot of traction behind UCIe. And a bunch of wires, I think, while it's seen more adoption, it's not something that we've personally seen as much enthusiasm around in the marketplace. So what are some of the challenges that verification IP can focus on? Well, right now with UCIe and a bunch of wires, there's kind of a lack of compliance specification for these interconnect standards. So while UCIe does have a compliance work group, there hasn't really been a lot put out in terms of a standard specification for UCIe compliance. A bunch of wires, same kind of situation. So what does it look like, if you're building a chiplet or building an IP block that's based on UCIe or a bunch of wires interconnect? What does it look like for you to be able to prove that you are compliant with the specification and will be able to interoperate with other chiplets that are using those same interconnect protocols? Another challenge is that, with something like PCIe, you can have an interop lab like PlugFest, where you can go in and after you develop your chip, you can go in and make sure that you're able to interoperate with other vendors. With chiplets, that's a little more difficult because you have to actually integrate on package before you can do any interop testing. And that leads to a pretty high tape out risk for chiplet designers. And so we think verification IP is really especially important in the chiplet space because it allows you to do compliance testing early on in simulation against your RTL. We also have demonstrated, that we can do interop testing between different vendors using verification IP as part of the stimulus. So those vendors, can both verify interoperability with the verification IP, verify compliance to the specification using our compliance test suites, and then integrate in co-simulation, simulating those RTL components of each of the vendor chiplets together using verification IP as the stimulus generation. So I will just cover on this really quickly. This is part of the Avery verification IP portfolio. We have UCIe and a bunch of wires verification IP. So Avery is a small company that was acquired.
Justin, we might have lost your voice.
Okay, can you hear me?
Yeah, you just came back now. We lost everything you said after Avery is a small company acquired by.
Okay, I'll start over again. Must be having some network issue here. Yeah, so Avery was a small company acquired by Siemens EDA about 3 years ago, and Avery's focused on verification IP development, and so we have a very large portfolio of protocol verification IPs, covering pretty much the span of of every major protocol that's out there, and so I'll be focusing today on the UCIe and bunch of wires. We also have verification IP for other 3D IC related protocols like HBM, and we also have PCIe, CXL, Ultra Accelerator Link, Ethernet. So there's quite a lot available. And one of the unique things about the Avery solution is our architecture is very simple. It's based on System Verilog and UVM. So those of you who are out there as RTL designers or verification engineers, it's very easy to integrate and come up to speed with the verification IP. It's easy to navigate if you're familiar with System Verilog and the UVM methodologies. We also focus very heavily on constrained randomization. So the VIP is really intended to model various different configurations of the IP, covering all of the optional features within the specifications, with a higher degree of randomization, so that if you're doing interop testing with the verification IP and your IP blocks, that you can be sure to cover a lot of different corners that you might encounter in when integrating your final chip. We do have full support with the verification IP of all the major simulators, as well as accelerated verification IP components for Veloce for emulation side. And then we also have what we call software-aware VIP. So this is a specific tool that allows us to run actual firmware and software on a QEMU virtual machine, and then connect that through DPI to the verification IP environment, so that we can run real software workloads in simulation. So you can test your RTL with actual firmware. So jumping into the UCIe VIP specifically, we have been active at Siemens with UCIe since the very beginning. We were, I think, the first verification IP solution on the market, and worked really closely with some of the early contributing members of UCIe to develop and mature the verification IP. So we have full support for all of the protocols that are supported in UCIe, including PCIe, and this is a little outdated. It should be PCIe 7.0, and CXL3, and streaming modes as well. So we actually can natively support with our PCIe protocol VIP, CXL protocol VIP, AXI, CHI, and soon hopefully Ultra Accelerator Link as well. So that you can model those, from a system level perspective, as well as just the UCIe link interconnect. We support all of the FLIT formats defined in the spec, and there's also a lot of configuration available for the logical PHY, depending on whether you're doing standard 2D packaging, 2.5D advanced packaging, or 3D packaging. With the VIP, we can very flexibly configure things like how many modules you have, how many lanes are supported. And the verification IP covers link training. So this, doesn't need to be manually generated. You don't have to create your own sequences. The bus functional model can autonomously handle the link training events. So sending training patterns, responding to the training. It can handle lane repair automatically, lane reversal automatically. And then we have, the LFSR scrambling and descrambling as well for the LFSR pattern generation, and also for regular scrambling during active data transmission. The VIP also supports the dynamic clock gating, so you can make sure that you're handling that power saving dynamic clock gating. For the die-to-die adapter, we can support up to 2 protocol stacks. So in the UCIe spec, you can have 2 protocol stacks, and you can carry multiple protocols across a single die-to-die link, as long as they share the same FLIT format. We support the adapter level retry, CRC checking, and replay, as well as autonomous parameter negotiation. And as I mentioned before, the BFM is highly randomized, so we are able to randomize, which capabilities the BFM supports, so we can negotiate different FLIT formats and protocols with the remote partner. Another unique thing about UCIe that's different from some protocols is all of the intermediate interfaces between the protocol stack layers are fully specified. So we have the FLIT-aware die-to-die interface and the raw die-to-die interface. So the FDI is between the protocol stack and the die-to-die adapter, and the RDI is between the die-to-die adapter and the PHY layer. So in addition to having the physical, serial interface defined, we also have these 2 interfaces. So in the VIP, we have made it flexible and configurable so that you can enable or disable various layers within the stack and connect to your DUT at any of those layers. So you can actually verify not only compliance at the PHY layer, but you can verify your compliance of your FDI and RDI interfaces. So this is useful if you're doing IP development where your IP is going to go into a larger subsystem that has the full UCIe stack. We also support retimer mode, so you can verify a UCIe retimer against the VIP or model a UCIe retimer with the VIP. And then UCIe also defines an extended config space, a DVSAC, as well as die-to-die and PHY registers that are used as part of the stack configuration. So with the VIP, we model those and provide APIs so those can easily be accessed, and so that you can easily generate register access requests to configure or read the config space of the remote die-to-die. And then we have lots of callbacks throughout each of the layers of the VIP, so that you can do things like error injection and scoreboarding. So you can really test not only, are you able to link up your UCIe link, but, how do I handle error scenarios? How do I handle, malfunctioning lane, handle lane repair? How do I handle, corruption of the data so that I have a CRC error and need to trigger a replay? So we have a lot of flexibility in our VIP to handle those kind of things. Then we also have debugging tracker files, so you can look at your data in a text format that's easy to read and easy to debug. And then we also, most importantly here, we have a full protocol checklist. So this is assertions that are derived directly from the specification. They are verifying things like the spec says this must happen when this happens, that kind of thing, and we will fire assertions if there's any violation of those requirements in the specification. So those are kind of handled directly in the BFM as well as in our compliance test suite. And the compliance test suite, as I mentioned before, for UCIe specifically, there's no compliance spec at the moment, and so we have derived our own test suite from the rules and requirements within the specification. And so those cover the logical PHY, the die-to-die layer, the DVSAC and register space, as well as the protocol layer, and then now extended in UCIe 2.0 to the management layer as well. This is just specific to UCIe. So this is kind of the full stack BFM architecture. So as I mentioned, we have the FLIT-aware die-to-die interface here, and so this can interface with the protocol stack. So whatever you have, PCIe, CXL, AXI, and then we have the argmax here logic in case you have a CXL protocol that's going over here, and then a stackmux that multiplexes between the protocol stacks. And then we have the replay handling logic that sits within the die-to-die adapter layer here. And then the raw die-to-die interface. And then the logic phi down here, which can be instantiated with 1, 2, or 4 independent modules, each with their own link training state machine. And then that's where you would connect your main serial interface as well as your sideband interface. So that's it for UCIe. I just for the sake of not needing to have an NDA with everyone on the call, I won't go into more detail on UCIe, but you can always reach out if you have any more specific questions or if you want to have a more detailed presentation on the VIP. So next, I'll just touch on a bunch of wires really quick. About a year ago, we started the process of developing a bunch of wires VIP. We followed a similar kind of architecture as we did for UCIe to make it flexible for customers to be able to do block level testing. So we implemented the phi layer, the link layer, and the transaction layer independently. We provide the system interface, which can be extended based on the customer use case, as well as the transaction link interface and the link to physical interface, and then the bunch of wire serial interface. So again, the VIP here is very configurable and flexible, especially because bunch of wires leaves a lot more to the implementation than UCIe does. However, we haven't seen a lot of traction. We've been looking for early partners to work with to kind of mature the VIP, and we haven't seen the same level of interest with bunch of wires as we did with UCIe. So if anybody on the call is interested in bunch of wires and being one of those early partners, please do reach out and we'd be happy to discuss with you what that might look like. And then I'll just end with, there's lots of topics that we've covered in the past on UCIe in various webinars that are public. So I've left some links here. We also have most recently a white paper that Siemens did on UCIe 3.0 and specifically looking at some of the new features of UCIe and the manageability requirements that were introduced in UCIe 2.0 and the complexity that can add to your verification requirements. If you're developing a chiplet, that's going to be compliant with the UCIe manageability features. And there's also lots of other topics out there. I'm sure most of you are familiar with, all that's out there related to UCIe and bunch of wires. If you have more specific interest in looking into those. So that's what I have for today. Do you have any questions about that so far?
Justin, just a quick question. CDX ML is something that Siemens has participated in helping develop here at OCP. Is there any use of CDX ML in this work?
Not in this work particularly, no.
Okay, and follow-on question. This tool, if someone wanted to use it, is this something they would have to pay for?
Yes, this is a licensed tool.
Okay.
Okay. Hey, Justin, I had a quick question. Have you done any work with UCI 3D in terms of VIP for that?
Yeah, so I'll touch on that a little bit. For UCIe 3D, what we found is there's not really a ton to do in terms of verification IP because basically in the UCIe 3D it strips out the entire adapter layer and the phi is just a very simple logic, and the protocol use case for UCIe 3D packaging is very open-ended and implementation specific. So from a verification IP perspective, there's actually very little for us to do there. We could model, the number of lanes you have there, and we could do a very simple phi driver, but what's actually happening above that is going to be very open to the implementation.
Yeah, so that's an area we're interested in with manageability, because you still need to be able to manage those links, right? So even though the PHY itself is very simple and its
The-
control. So
Yeah, that's right. And yeah, it's an area we'd be, interested in talking to you about, Cash. It's just something we haven't put a lot of effort into because we haven't seen, for one thing, we haven't seen too many customers that have really moved into the 3D packaging space yet. So
okay.
Hey, Justin.
hey,
This is Raghu. Hey, good
Hey, Raghu.
presentation. This verification IP could be an interesting concept. One of the work streams we are trying to launch the next couple of weeks is something that I'm calling virtual chiplet ecosystems, where we're trying to get higher level models, right, at the architecture level, like System C models, and see how multiple organizations can check in their models, and a lot of things to be decided. We thought worked through, but just the high level. And I think verification IP could be one critical component if we can do this as a system level. If we can say, hey, we are validating against this verification IP, and so my chiplets at the architecture level are validated to this, right? So that will be a good kind of a checkpoint. So I see sort of some synergy there. I just want to get your thoughts on that.
Yeah, that's definitely an area we're very interested in. I mean, probably one of the challenges, as Cliff just asked, is this open source? Is it free, right? And the reality is, this is a product that Siemens offers, and it's licensed. It costs money, but that's one of the selling points that we try to make to customers about the use of verification IP, because we model the full the full protocol, because we have our compliance test suite. Really, the goal of verification IP is to help give you higher confidence that you're going to be compliant to the specification. You're going to be able to interoperate with other people who are implementing the spec, and maybe complying with our verification IP as well. One thing that's unique about Siemens EDA's verification IP solution versus some of the other competition is Siemens is not in the IP development space. So we're not, we don't have any bias towards our own IP. So that gives us room to work with a lot of different partners. So we work with almost every major IP vendor out there in the UCIe space. We work with a lot of other, chip companies that are doing their own UCIe solutions in-house. And so, between that, we're able to work out a lot of the questions that come up, about ambiguities in the specification. And we work closely with the protocol work group at UCIe Consortium to make sure that we get those questions answered, and, find the balance between the difference of opinion that people have about their interpretation of the spec. We're also now starting to look at the manageability layer. So taking, what we've normally done with customers, when they're verifying the UCIe link, is, you're just doing one UCIe VIP component, connected up to an IP block, right? But now, how do we take that into, developing a chiplet environment and simulation where you have multiple chiplets potentially with multiple UCIe links, and then introducing the manageability software in that environment. And so that's where our software-aware VIP solution comes in. How can we run actual manageability firmware in a simulation environment with RTL, with verification IP? And then the other thing we're looking at too, as I mentioned early on in the presentation, the interoperability project that I presented at Chiplet Summit, and taking two separate chiplet vendors and connecting them together and choosing, and confirming the interoperability in the simulation world, right? And one of the things we're looking at is Siemens also, Avery has a tool that's called SimCluster. And what that tool allows you to do is actually partition your simulation onto multiple different machines. So you could, for example, take RTL running on one site from one company, RTL running from another company on another site, and simulate those together over the internet, basically. And so you can co-simulate, you can do interop testing where you don't actually have to load your IP, onto some other company's environment. You can actually keep it secure, keep it separate, and simulate together, and then use the verification IP to drive any protocol level stimulus in that interop testing. And so that's what we're kind of looking at as far as bigger solutions for helping do this kind of early interop and compliance testing. So yeah,
That
I
can
think
be
that would
very
fit
cool.
really, yeah, I think that would fit really well into what you're doing with the virtual
Yeah, no,
chiplet
that can be
ecosystem.
very cool. Sorry, sorry, Justin. I was like excited to talk, say something. Anyway, so it's very cool. I think that the kind of a disaggregated simulation testing, simulation environment that you described, that could be very, very, very interesting. And by the way, I think we are trying to at least, and I may should have a longer discussion offline maybe, but I think just to simply state one thing, we want to at least get the kind of collaboration coming in through the kind of framework open framework that we are proposing or we want to go build. And as part of that, some of the for paid um, testing, like you said, right? That could be decided by the chiplet vendors, right? But we at least want to bring the first point of contact very quickly and say more people can come in there and then say, hey, I want to go and use Siemens or other things, right? So that's kind of what we are thinking, but it'll be good to have. I mean, if you're okay, I can connect with you offline and see if there is more synergy out there.
Yeah, and I think it's something we're definitely open to and have done in the past with Avery. So, Avery has done compliance programs with CXL in the past using our software aware VIP solution. That, again, basically we create the setup. The CXL consortium, for example, uses it to test their compliance C sequences using running the real software with our VIP against our VIP, and then makes that open and available to other CXL chip makers, right? So they can do the compliance testing using our solution. And so the solution's available. It's pre-tested by the consortium. And then it's open for other customers to purchase if they choose to make use of that.
I'm dropping my email, Justin, if you're able to connect offline. I'd like to just have at least share what we are doing and see if you might be interested in participating in the work stream that at least we are championing.
All right, sure. Thank you.
Now, if there were to be a version that was specific to some of the work being done in OCP projects, then I think there'd be a case for adding this service offering to the Open Chiplet Economy marketplace.
Yeah, I
Not sure if
agree.
that's interesting to Siemens. We get over 20,000 views a month to the marketplace.
Yeah, that would definitely be something we're interested in being involved in. Yep.
And Justin, it was interesting you said, as far as the bunch of wires VIP, you I think you mentioned to me, maybe it wasn't on this in this meeting, but maybe when we talked before that, you did reach out to people using that PHY, but didn't get much interest. And I know, I mean, there are companies that have used that PHY in one form or the other for product that's on the market, for example, D-Matrix. So I'm guessing they have their own form of verification and don't quite need to rely on third party. I mean, any thoughts there?
Yeah, so I think what we've experienced is that most of the folks we've reached out to about Bunch of Wires VIP, they have their own internal bus functional models for it. It's a bit of a simpler protocol to implement than UCIe.
That's right.
But another thing we noticed is that in a lot of those cases, the companies developing the Bunch of Wire solution were using their own PHY IP on both dies, right? So interoperability of their own FIs together was more important to them than interoperability with another vendor solution. And so if that's the case, then compliance to the standard or interoperability with other vendors becomes less important.
It doesn't
And
really
in that
matter.
case,
Yeah.
if the bus functional model is easy enough to implement in house, then there's less incentive then to go and purchase a third party verification IP to confirm that you're compliant to the spec.
Yeah, no, that's right. It makes perfect sense because even the case I was referring to is them talking to themselves, right? So it's less about compliance at that point.
That's right. Yeah.
Yeah. No, makes sense. Thank you. I appreciate that. Any other questions for Justin? Okay. If not, any other topics, Cliff and Javad, or maybe we can be done early today?
Nothing from me.
Yeah,
Um,
that's,
Ju-
yeah, no, thank you.
Perfect. Justin, if you could email me the presentation, I try to sometimes be diligent and upload it to the Google Drive that the OCP has. And so if you don't mind, if it's made truly public, send me whatever you can or a cleaned up version.
Yeah, I'm gonna pass it through our product management team and just make sure there's nothing in there that can't go out. I think it should be okay.
Okay.
And then I'll share it with you.
Sounds good. Thanks everyone. Happy Halloween. Enjoy the weekend.
Thanks all.
Thanks everyone.
Bye.
Appreciate
Thank
it. Bye.
Thank you. Bye.